Good morning. It is 10 o'clock Central Standard Time, March the 30th, 2021, here in Seagoville, Texas, on a cloudy, kind of yucky morning after the few mornings that we've had prior to this. Welcome to the Dallas Schools Environmental Education Center, STEM Environmental Education Center. And we hope you enjoy the day. We want to say a special welcome to William Anderson, S.S. Connor, and Edna Rowe for joining us today. We wish that you could be here in person, and we look forward to being with you next year in person. Teacher, if you're watching and you have not signed up, please go to www.tiny.cc/EEC register, sign up. This is just for our attendance records only. The program this morning will be ecosystem interactions. During this virtual field trip, students will observe the way organisms live and survive in their ecosystems by interacting with the living and non-living components, describe the flow of energy within a food web, and predict the effects of changes in ecosystems caused by living organisms, including humans. Mr. Broughton will do a walk around and discuss living and non-living things located here at the Environmental Center. Mrs. Nash will do food webs. Mrs. Ramirez will do another edition of food webs, and changes in the ecosystem will be conducted by Ms. Fuller. Now, during this field trip, you cannot ask us verbal questions, but you can go to www.tiny.cc/EEC /question/answer and ask us questions. Now, I'm going to stop sharing my screen, and we're going to let Mr. Broughton do a walk around for us. Come on, Mr. Broughton.
Thank you, Dr. Gorman. Yes, my name is Mr. Broughton. During this segment, we are going to learn about living and non-living things. So let me flip my camera around here so you can see the outside of our center here at the STEM Environmental Education Center. And right away, you probably have already noticed some living things and hopefully some non-living things. So I'm going to kind of discuss the non-living things first. Non-living or abiotic is another word for non-living. Components of an ecosystem would be sunlight. So it's kind of a cloudy day today. Like if I show you the sky, it's not sunny out, but we still have sunlight. It's daytime. Air. You might be able to hear the wind blowing a little bit. There's air for me to breathe. On the ground, there is soil for plants to grow in. The temperature is a little bit cooler than yesterday. Might even be below 70 right now, but it's still a pretty nice day out. And water is another component. And we're about to come up to a place where maybe I can show you our pond through this iPad that I'm holding here. So again, those non-living components of an ecosystem would be sunlight, the temperature, air, water, and the soil. And maybe you can see now off in the distance our pond behind those trees. It's not super full right now because we haven't had a lot of rain lately, but as we get more rain this spring, it'll start to fill up. And lots of animals will come and drink from that pond. And we also have, you can see between those kind of two stands of trees there, a deer feeder, because we do have living components here too, like deer and let's see what else has been eating from that deer feeder. Raccoons, foxes. I know a bobcat has come around before. I'm sure there are skunks and rabbits that have been around there. Lots of living things. And what makes something living is that it's made of cells. It needs to eat or take in nutrition somehow or make its own food if it's a plant. Reproduce, move, react to the environment, grow. Those are all characteristics of living things. So if you are looking at something and wonder if it's living or non-living, you think about what characteristics a living organism needs to live or to be alive. Think about those. So you can see the windmill up ahead now. It's moving, but is it alive? No, it is not, because it's not made of cells. It's never going to grow. It's never going to reproduce. It doesn't need to eat or get rid of waste. Those are the characteristics of a living thing. So even though that's got one characteristic like movement, it's not alive because it doesn't have all the characteristics. But what other living things we might see are some birds. And if I'm quiet, you'll at least hear some birds. So I'm going to continue this walk, and you can talk to your neighbor if your teacher says it's okay, and learn and just discuss what living and non-living components you can see as I finish this walk around our building here. I'm not sure if you can see in those trees up ahead there, quite a few birds in those trees. So if you heard chirping earlier, that's where it's coming from. And I can see cardinals on the branches. Let me see if I can walk up to them. They'll probably fly away, but we'll give it a try. Not sure if you can see those or not, but you see the female cardinal there? Sometimes it's harder to see with an iPad, but there's quite a few birds in those branches. So I'm going to continue this walking before I run out of time. Birds will definitely be part of the living ecosystem because they're made of cells. They need to eat. They need to get rid of waste. They can reproduce. They respond to the environment. Like when I walked up to them, they got quiet and they even started to fly away because they don't know if I'm a predator or not. And we're going to find one more living organism up ahead here that is a good example of why temperature is such an important non-living part of an ecosystem. It was warmer and sunny yesterday, and we have a red-footed tortoise that was out basking in the sun, head out. He was very happy to be in finally some good sunlight. And today, since it's so cloudy and a little bit cold, if I find him here, yeah, there he is. Let me just get through these branches. You can see he's all kind of huddled up in that corner there. It's warm enough for him to survive. Although Wednesday we're gonna have to bring him inside before we leave because it's gonna be too cold at night. But he's not so super happy today because it's a little bit cold out. And that kind of tortoise needs warm temperatures to live and be happy. And there we have a female turkey, not a wild animal. These are domesticated chickens and turkeys that we have here as part of our farm, but still they are living organisms. And here comes some ducks. They'll probably come and say hi because they almost always do. Yeah, how are you doing? All right, so that's the end of my walk. You've gotten to see some living and non-living components, and now I'm going to turn it back over to Dr. Gorman to answer any questions.
Thank you, Mr. Broughton. What an interesting walk. However, most of us get to see that on a daily basis, so it's kind of commonplace to us, but to a lot of you, it's very unusual. The question is, would you describe the difference between living and non-living things? And I'm going to let Santia do that. The term living thing refers to things that are now or once were alive. A non-living thing is anything that was never alive. In order for something to be classified as living, it must grow and develop, use energy, reproduce, be made of cells, respond to its environment, and adapt. Thank you again, and we're going to let Ms. Nash now tell you about the food web's owl pellets.
Our classroom, and a great way to discover lots of interesting things about the food web, the food chain, are by investigating owl pellets. So you might ask, what's an owl pellet? So an owl pellet is made by the owl. They come like this from the biological supply store, and they're wrapped up. You unwrap them, take that aluminum foil off. You see this, quite compacted together, and it's not excrement. What happens is the owl can mouse or a rat whole. They don't chew it up. They don't have teeth, they have a beak. They swallow whole, it goes into the first stomach and then the gizzard. And in the gizzard, the bones and the fur are left behind, and the teeth, the indigestible bits. And the rest of it passes on through to be digested and give energy to that owl. And then that pellet, all that fur and bones are compacted and they cough it up. So they regurgitate it. And they're not nasty. People think, oh, that's disgusting, but really, just interesting. And these have been sterilized, so there's no germs here. So I'm not afraid to touch it with my hand. And you can occasionally find them in the woods, under a tree where the owls have been roosting and then coughing up their pellet. Other birds of prey like hawks and eagles also form pellets. Now, what's in this pellet? Well, it's pretty mysterious, but with your clever fingers, you can begin to break it apart. And break it apart, you're going to get fur and bones. I'm going to show you here. So I've got fur and bones, and then I'm going to try to separate out all the interesting bits. And my technique is to use my fingers. Now your fingertips are incredibly sensitive. And I can find things with my fingers that I can't find by looking. It's really amazing. And what you're going to start to find are bones. And these bones are pretty small animals. Because of course an owl, it's not a very big animal. Even the biggest owls are only about 2 feet tall. And so these are small animals. And mostly they're going to be, what you guess, rodents. That means rats and mice. And that's because there are lots of them. They reproduce really rapidly. We never run out. And they are mostly nocturnal, as are the owls. So we occasionally find a bird. We occasionally find a bird skull in a pellet, but birds are much rarer in the pellet. Now, why would you think? When you think of a region, okay, turn to your neighbor and see if you can figure out a good reason. You might have said that most birds are not out at night, and that would be true. Most birds are called diurnal, not nocturnal. A few owls are diurnal also, but most of them are pretty nocturnal. So most birds are hiding away, and not available for eating. The exception are the little owls get eaten by the big owls. But next. Yeah. So once I start taking all the things apart, then I'm going to look at my chart, separate all out all the bits I can. clean them off a little bit. And then I'm going to look at my chart. And so I'm going to try to sort them. And notice a lot of the bones are going to look pretty similar. So what I always tell students is unless you can show me the skull, like that bird's skull I showed you, or a feather, or something really definitive, like this forearm of a mole, you have a rodent. Just assume it's a rodent. Now, when you find a rodent, you're going to see some yellow teeth. That little skull, those yellow teeth, those strong teeth that keep growing. And they use those to gnaw on seeds and nuts and things to get their food. Now, once I found the skull, I'm going to put it on my chart in the correct spot. And I'm going to go through my whole pellet. And what I'll find often is 3 or 4 skulls of rodents in one pellet. They eat a lot of rodents. And I'll put all the other bones in. Now, most of the bones we find are the larger bones from the animal, like those skull, teeth, these little hip bones. See that little hip bone there? Hip socket. Okay. And occasionally we find, very rarely, we have found something really amazing, this mole shoulder. The shoulder blade and the front claws of the mole. Look at that. The doppel. And they dig, right? So they've got this incredible shoulder blade and these claws, unlike any other animal. Right? So if you found this, you would know that they ate a mole. Of course, moles spend most of their time where? Underground. So they're not a very popular prey item either. Now, another thing we occasionally find are little tiny, tiny animals called shrews. If you look at the chart, you can see that the shrews and moles have different teeth. Of course, birds don't have teeth, but they have their little insectivores. That means they eat insects. And so they've got little sharp teeth, okay? But the shrews in particular are tiny, tiny. The whole animal's only about that big. So the little skull is only about that big. And again, it's something you find by feeling really carefully. And I don't know if you can see these, but in this tiny box, we have some teensy weensy, that's a skull of an animal, that the whole skull is that big. So very rare to find it. And you only find the skull. The other little bones are too tiny, really, to ever find. Occasionally we found that hip bone again, because it's one of the biggest bones in the body. So really interesting. Here's one of the weirdest things you've ever found. This one, I saved it. It was so different. This one, you can tell the color of the fur is really different. And when we examined it, we found some sharp teeth, okay? Now, these are not the teeth of a rodent. See that teeth? So, and because of the color of the fur and the teeth, I think this was a young possum, okay? They got eaten by an owl. And of course, possums are nocturnal, but they get pretty big, so they're not really a popular dinner item for them. Now, owls are really amazing birds, and you can observe them, listen for them in the neighborhood. We have 2 really common owls around, the barred owl, medium-sized owl, and they say, woo-hoo, 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 woo-hoo. You'll hear them at night. And then the smaller screech owls, who touch their feathers on the tail, really cute and adorable, they get eaten by the great horned owl, sadly. But they say, they have a really weird sound they make. They say, woo, like a wheeling horse. Okay? So you can listen for those and think about what they're doing. They're out there calling for mates and establishing territory. And they're hard to spot. Sometimes the crows are chasing them. And you can see what the crows are chasing. It might be an owl. Now, they're really adapted for hunting at night. And they're silent flying. They're silent flight. The edge of that wing, you see the feather? The edge of that feather is feathered, okay? Fuzzy, and that makes them quiet. So this is a barred owl feather and a crow feather that makes a lot of noise when they fly. So they fly silently. They're looking with their giant eyes, and listening with their sharp ears for prey, they swoop down silently and they kill with those talons. Okay? So that's how they kill right there. And then in the daytime, they're really camouflaged. Okay? You can see how they can hide and look just like a tree. Okay? And they snuggle up in the branches during the day. So really interesting animals to study and learn more about. And if you come out for a field trip, we might do this in a lab, or sometimes you can do that with your teacher. It's a really fun thing to investigate. And again, use your fingers because they're the best tool we have for this job. So thank you. And if you have any questions, you can ask Dr. Coleman.
Thank you, Ms. Nash. And the question is, where can I get one of the owl pellets? If you are going to school in the Dallas Independent School District, talk to your teacher. They can order them from the Living Material Center. If you're an outside district, you can go to Carolina Biological Supply Company and buy them from them. Now, we're going to have Ms. Ramirez also talk about a food web or a food chain.
Hello, my name is Ms. Ramirez, and we're going to be taking a closer look at what exactly a food web is. So before we get started, I do want to show you guys a live animal. Her name is Pepper. She is a blue silky chicken. You've probably met her before if you joined us before. So I'm going to go ahead and pull her out and introduce y'all to her again. So as I show her to you, be thinking about what do you think her role is in a food web? So what do you think she's going to be eating? And also, what do you think might eat her? So again, she's a blue silky chicken. They get that name because they have a blue patch of skin covering their ears. And if you guys were to pet her, she feels super soft, just like silk. So she is a chicken. She's a bird, and we know that because she is covered in feathers and not fur. So I'm going to go ahead and put Pepper, the chicken, up, and we'll start our presentation. So I'm going to go ahead and share my screen with you guys. And of course, we have 2 essential questions for you guys. So hopefully by the end of this presentation, you guys will be able to answer these 2 questions. So the first question is, from what energy source does all other energy originate? And you should be able to explain that. And the second question is, what is the role of decomposers in a food web? So keep those 2 questions in mind as we go through the slides. So let's go ahead and take a look at a food web. So a food web simply shows the transfer of energy within an ecosystem. And energy is transferred between organisms when one organism eats another. So essentially, a food web is just a collection of several food chains, and it shows us who's eating who or who's getting energy from who. So let's take a look at this food web over here. Make some observations. What are some things that you notice? Also think about, what do you notice about the direction of the arrows? And feel free to pause the video to allow more discussion time, but I'm going to go ahead and jump right into it. So hopefully you guys notice we have our sun here, and that sun is actually super important. So all energy in a food chain or food web originates from the sun. So again, even though that sun is abiotic or non-living, it is very important for all living things on Earth. And again, it's important to note that the living components in an ecosystem need those non-living components or those abiotic things in order to survive. So don't overlook those abiotic things. So again, that sun is the source of all energy. That sun is providing energy to our producers. So take a look at our diagram here. Can you identify any producers? So producers are simply plants. They're your plants and trees. They are the organisms that undergo photosynthesis using energy from the sun. And the way that I remember it is producers, plants, and photosynthesis all start with the same letter P. So they're all related. So here we have our producer over here, and we notice that something is eating that producer. We have a grasshopper, and look at the arrow. The energy from that producer, that plant, is going into the grasshopper when it eats it. So it's important to note what those arrows mean. So the arrow shows the direction in which energy is flowing. So we have the energy from the plant flowing to the grasshopper. Then we have the energy from the grasshopper flowing to the mouse when it eats it. And then the energy from the mouse will eventually go to the raccoon because that raccoon's going to eat that mouse. But then the raccoon's energy, according to this food web, is going to go to the owl because the owl's going to eat that poor raccoon. So you can see the energy transfer within a food web by following those arrows. And let's take another example. Here's another food web with a chicken. So indeed, Pepper is part of the food web as well, just like us as humans are part of the food web as well. So again, take a moment, see if you can identify the producers, see if you can identify the consumers, see if you can identify that energy source that is responsible for all the energy within our food web. And then also see if you can describe any feeding relationships that you guys notice. And again, feel free to pause the video for discussion. While you guys are thinking about that food web, I just wanted to show you guys a picture over here on the right. This is blue silky meat. So remember Pepper the chicken? If I were to cook her and eat her, her meat would look like this. It looks rather weird. It's kind of like the skin, the meat, and the bones are kind of like a dark purple, almost black color. In the US, we do not use the blue silky as a source of food. However, in Asia, it's considered a delicacy and they use them in a lot of their meals. So you can see a difference in how the blue silky chicken looks compared to the typical chicken that we would see here in the grocery store. And of course, people are, for the most part, omnivores. Most of us are going to be eating meat and plants. So you can see a chicken sandwich over there. If you guys like eating chicken nuggets, you are eating a chicken. Of course, if you are eating burgers and steak, you're eating a cow. So we are part of the food chain or food webs as well because we're eating other organisms for energy. So let's take a look back at our food web over here. We have, of course, the sun, which is the source of all the energy, and it's providing that energy to our producers so that they can undergo photosynthesis and produce their own food. And those producers in turn are giving energy to other organisms called consumers. So consumers are just animals. They are things that cannot make their own food. So consumers have to eat other things for energy, whether it's plants, animals, or both. So here we have our grasshopper friend. That's a primary consumer. So if we take a look at our food web over here, the grasshopper is a primary consumer because it is the first consumer that is eating this producer here. Now take a look at the chicken. The chicken in this food web is a secondary consumer because it is eating that first consumer. And of course, we know the chicken's an omnivore, so Pepper, the blue silky, eats insects, but she also eats fruits and veggies. And then let's take a look at the little kid here. The kid is a tertiary consumer in this food web because he's eating the chicken. So you can see one consumer, two consumer, three consumer. So that's what we mean by primary, secondary, and tertiary consumer. And then take a look at our cute little fox over here. That is also a tertiary consumer. It is the third consumer in line, and it's eating the chicken, which ate the grasshopper. So that's what those words mean there. So I have a quick question for you guys. What could be an example of a quaternary consumer for this food web? So quaternary just means fourth level consumer. So think about what would eat the fox over here? What could you put in there to make it above? So our next thing we're going to take a look at is another food web, but this time this food web actually depicts decomposers. So think about what is the role of decomposers in a food web? And then take a look at this food web. Can you guys identify any of these decomposers and describe why are they important? So for example, a lot of our decomposers are right here. We have some fungus, some bacteria, different kinds of invertebrates like insects and pill bugs. And of course, decomposers are super important because their job or their role in an ecosystem is to break down or decompose the dead plant and animal material. And when they're breaking that dead stuff down, they're returning nutrients back into the soil for our producers to use so that they can then grow. So without producers, if we didn't have those decomposers, our producers wouldn't have nutrients, but also our planet would be probably super smelly and just a whole bunch of dead stuff piled up. So we really need those decomposers to help get rid of dead plant and animal material and waste. So they do have an important role. And then here's an example of some decomposers in my vermicompost. So a vermicompost is just a box that I have in my classroom. It has soil in it, and I filled it with about 100 red worms. And whenever I have leftover food, I just throw it inside that box, and those worms will break it down and give me some nice nutritious soil that I can use maybe for plants or gardening. So here I'm going to show you guys a quick little video, make some observations about these different decomposers. So we have those red worms there. That's actually a donut, and you can see that there's lots of mold on that donut, and those tiny little things you see crawling around are mites. They are also decomposers that will eventually completely break down that donut. And then we have some red worms, and all of those tiny, tiny little things you see crawling around are insects called collembola or springtails. They are also decomposers, and they are just helping to break down. I had some shredded newspaper and some old leaves and some other vegetables in there that were being broken down by all of those decomposers. Again, another question for you guys is, can there be producers and consumers in a vermicompost? So what do you think? And see if you can explain that. And then in our last thing, I have a challenge for you guys. Research the ecosystem in which a ball python snake lives, and then draw and label a food web that includes a ball python snake and at least 5 other organisms. So I'm going to show you guys a video of my snake Basil. She's a ball python, and she's going to be hunting and eating a mouse. So if you don't want to see this, you can just put your head down on your desk, and I'll let you guys know when it's over. But again, this is just it's a part of life. My snake has to eat, so you'll be able to see her hunting and eating this mouse. Now, this video is time-lapsed. I kind of squeezed it into a short video of only 30 seconds, but in real life, it actually took Basil 10 minutes to completely kill and swallow this mouse whole. But you can see how Basil is using her teeth and her jaws to help her move that mouse through her mouth and push it through the rest of her body. Basil is a carnivore, so she only eats meat. And something else about her, these snakes are native to Africa, but in the US, they're very common as pets. And you can see her sticking her tongue out there in just a little bit. That's how they smell. She's an excellent predator. So that is her role in a food chain or food web. She is a predator, and she eats other smaller organisms. So I'm going to stop my screen share. And before we go, I have another snake to show you. This one is a snake that lives here at school. This one is Pelota, and she is a ball python too. She's a lot bigger than my snake Basil, but she is the same type of snake. So again, be thinking about what other organisms can you find where this snake is native to, and see if you can draw a food web that incorporates the ball python. So I'm going to go ahead and give it back to Dr. Gorman, and he's going to answer any questions.
Those pythons are pretty neat, especially that big one. Now the chicken, the skin of that purple chicken, if my wife put a plate of chicken on the table that looked like that, I'd promptly get up and go to McDonald's or somewhere. I would not eat. That was some ugly chicken. Okay, the question. The last 2 or 3 nights, it's been a full moon or a near full moon, very bright, very beautiful. Does the moon furnish any energy to the food web? Let's do a quick Google search here, or I did a quick Google search, and let's see what they have to say. The vast majority of energy in food webs originate from the sun. Energy is not recycled in ecosystems, and each ecosystem requires a continuous input of energy to sustain it. There is some energy transferred at each level of the food chain or food web in an ecosystem. So no, the moon did not furnish any energy to the food web. And now we're going to have Ms. Fuller tell us about changes in the ecosystem.
Good morning, boys and girls. We're going to be talking about changes in the ecosystem caused by organisms, humans, and then animals. So I'm going to start off by showing you a beaver pelt. A pelt is the skin of a mammal that still has the fur attached. So there's the skin, and here's the very thick, luxurious fur. People used to wear coats made of this or hats made of this. It's a lovely, lovely pelt, and it's big. I'm going to step back and show you how big the beaver pelt is. Can you see that? A lot of people think beavers are little animals, but they're not. They're really quite large. I think because most people see them on TV and they think that they're only this big, but they're actually pretty big animals. So I'm going to show you the skull of the beaver. This is the beaver's skull, and I want you to look at these teeth. Now, he's an herbivore. He only eats plants, but and here's a stick that he ate. Can you see this? This is actually a tree that he chopped down with his very sharp teeth. See all those teeth marks on there? Well, let me show you these teeth. The ones in the back are grinding teeth. He's an herbivore, so he has to grind up all these leaves and twigs and branches and everything. But the front teeth, now this is the right mandible right here, lower jaw, and it fits in right in here like that. Well, you notice the teeth are burnt orange. He didn't go to the University of Texas. They're burnt orange because there are receptor cells in the front of the teeth that absorb iron, which make the front of the teeth very hard. The back of the teeth, however, are white, just regular bone or tooth tissue. And as a result, as they gnaw on things, the front wears away slowly and the back of the teeth more quickly, forming a wedge shape, which is very beneficial. And if you've ever wondered how a rodent can actually chop a tree down with his teeth, that's how. So let me go ahead and share my screen with you. We're going to talk first about humans and how humans can change an ecosystem, and then we'll get on with the beavers and the other animals. So changes in ecosystems caused by living organisms, and what contributions to ecological change do organisms make? Now you notice we also have wolves and elk in here, and that'll become more apparent as the program goes on. So let's think of two questions. How can humans change ecosystems? Very profoundly, actually. And number two, what changes do beavers make in their ecosystem? So these are two questions to keep in the front of your mind as you watch the program. Now, the place where we live, our ecoregion, is called the Blackland Prairie, and it reaches from up here where we are, a little bit north of here actually, all the way down to San Antonio in a big arc. And we've got a very distinctive soil here called Houston Black. And Houston Black is a heavy clay soil. It's very dark. And a lot of people came here to farm and ranch because of this soil. So because so many people came here to not only farm and ranch, but actually to live in Dallas, Fort Worth area, et cetera, it endangered the ecosystem. It changed it so radically that the Blackland Prairie is the most endangered ecosystem in North America. Only 1% remains in its original form. So how did this happen? Well, in the middle, you got a picture of a barn and some corn growing. So the first thing that happened was agriculture. We had a huge shift from a prairie ecosystem with bunch grass and all kinds of prairie grasses, little blue stem, big blue stem, bushy blue stem, switchgrass, Indian grass, all kinds of wonderful prairie grasses that are indigenous to Texas and indeed to the entire Great Plains areas from here all the way to Canada, and changed it to domesticated plants like corn, cotton, milo, things like that. So the ground was broken, fences went up, less habitat for the natural plants and animals. Then we have something called urban sprawl. And here in Texas, we have a tendency, instead of building up, we build out because we have a lot of acreage. So we've got lots of houses going up. We've got airports, roads, highways, all different kinds of buildings, business buildings, schools, houses, everything. So if it's paved, then rainwater can't soak into the soil. So we've got a tremendous amount of asphalt and concrete covering the soil and keeping the soil from absorbing rainwater. And then down here on the right-hand side, you see the effects of overgrazing. And the overgrazing is not as great a problem now as it was at one time, but we still see the after effects of that in the form of erosion. So that's what happened to the blackland prairie. Now let's talk about invasive species. As humans came in, they brought non-indigenous plants and animals with them. Probably all of us have had an unfortunate experience with fire ants, but we also have these other invasive plants like Chinese privet, Chinese tallow, and the dreaded Johnson grass, which moves in and takes over. Now let's talk about beavers quickly. Beavers are large rodents, and they change their ecosystem. Some ecologists refer to them as ecosystem engineers. And what they do, they build these dams and block rivers, and it forms a pool or a pond behind it. And of course, the animals and plants that live in ponds and pools are very different from the ones that live in moving water. Now, moving water is called lotic water, and water that's still like a pond or a pool is called lentic water. So they changed that. That's a very profound change. And all kinds of silt and nutrients and things like that build up behind the dam. Well, the dams aren't really the only things they build. They also build lodges, not so much here in Texas because we don't have extremely cold weather usually. And they also build canals. So all of these things change the ecosystem. Well, when beavers move in and start changing things, if there are protected wolves in the area, the wolves will be attracted. And what happens, let's think of areas like Yellowstone. Elk have a tendency to stay in one area and just eat everything to bits. Well, if there's the pressure of predators like wolves, the elk will keep moving, which keeps the forest from being destroyed. So this is a real positive thing. And another positive thing is after the beavers leave, when they go somewhere else, the dams eventually fall apart, and that area where all the silt builds up becomes what's called a beaver meadow, and it's very high in nutrients, and it's a very good place. So we're going to get out of our little PowerPoint here, and I'm going to tell you that there are some things that we can do as humans to have not as great a footprint on the change of ecosystems. We need to be more mindful and careful of what we do. If you have any questions about organisms changing their ecosystem, Dr. Gorman will be more than happy to answer those questions. Thank you. Have a good day. Bye-bye.
Thank you, Ms. Fuller. And the question came in, a personal example of humans changing the ecosystem. And I have that exactly right now. Example of an urban sprawl that is taking up land and displacing several plants and animals in the Blackland Prairie. I live in Waxahachie, which is right in the middle of the Blackland Prairie. Probably the pictures of the bluebonnets that you saw very possibly may have came from Waxahachie, Ellis County. Okay. Recently, Jerry Jones, owner of the Cowboys, has approached Waxahachie. I guess there's not enough land left further north of Frisco and all. He bought several thousand acres just west of Waxahachie, between Waxahachie and Midlothian. Now, he is planning on bulldozering this land up, split it off into square lots, and making thousands of houses for thousands of people, which means that he's displacing thousands of animals and plants. Mr. Jones needs to stay up north. And that's just my opinion. And now I'm going to share my screen. During this virtual field trip, students observe the way organisms live and survive in their ecosystems by interacting with the living and non-living components, describe the flow of energy within a food web, and predicted the effects of changes in ecosystems caused by living organisms, including humans. Mr. Broughton took you a trip around the EEC, discussed living and non-living things. Ms. Webb did a food web with owl pellets. Mr. Ramirez did an additional food web, and Ms. Fuller did changes in the ecosystem. Now, teachers, how did we do? If you would, go to www.tiny.cc/EEC feedback and fill out a short form. We would appreciate it. That'll let us know what you think about the program. Okay, for the rest of you, I hope you have a great day, but more importantly, I hope you have a great rest of your life, and that includes the teachers too. Thank you for joining us today.